Welcome! Today we are diving into a really handy concept from trigonometry, figuring out the area of a sector. Or, to put it another way, we're going to master the math behind a pizza slice of any circle. So let's dive right in.
And hey, this is a real question. Have you ever actually thought about how much pizza is in that single slice you're about to eat? Or how do those massive sprinklers you see on farms water a perfect wedge of land? Well, it turns out the math we're about to cover is the secret to all of it.
Okay, so before we start crunching numbers, let's get our definition straight. First things first, what in the world is a sector? A sector is just that wedge-shaped piece of a circle you're looking at. You've got two straight sides, those are the radii, and the curved edge, which is the arc. You can just think of that as the crust. Honestly, the pizza slice analogy is perfect because that's exactly what we're measuring, the flat area of the slice itself. Now, it's really important we don't mix this up with something we've talked about before, arc length. Remember that? Arc length just measures the crust. It's a one-dimensional length. But today, with sector area, we're measuring the whole slice, which is a two-dimensional area. The units give it away. We use things like centimeters for length, but centimeters squared for area. It's a small difference in words, but a huge difference in what we're measuring.
All right, let's get to the good stuff. We're about to build this simple and kind of beautiful formula for finding the area of any sector.
You know, this formula isn't just magic, it's totally logical. We all know the area of a whole circle, right? Pi r squared. Well, a sector is just a fraction of that circle. So how do we find that fraction? We just take our sector's angle, theta, and we divide it by the angle of the entire circle, which is 2 pi radians. Then we multiply the total area by that fraction. The pi's cancel out, and we're left with our clean, simple formula. Area equals 1/2 r squared theta.
Okay, stop for a second. This right here is the single most important rule you need to remember. Your angle, theta, absolutely must be in radians. If you try to plug in an angle in degrees, I guarantee you the answer will be wrong. This formula was built from the ground up using radians, so please always check your units first.
Theory is one thing, but let's be real. The best way to get comfortable with this is to actually use it. So let's walk through a few examples, starting simple and working our way up. Let's start with a nice, straightforward problem. We need to find the area of a sector. We're told the radius is 4 centimeters and the angle is pi over 3 radians. Notice anything convenient? Yep, the angle is already in radians, so we're good to go. First, we always write down the formula. A equals 1/2 r squared theta. Next, we just plug in our numbers. R is 4 and theta is pi over 3. Okay, so 4 squared is 16. Half of 16 is 8. And that leaves us with our final answer. 8 pi over 3, and don't forget the units, centimeters squared. All right, example number 2. Picture this. A lawn sprinkler sprays water in a 120-degree wedge, and the spray reaches 8 meters. Now, what's the very first thing that jumps out at you? That's right, the angle is in degrees. That's our first hurdle. And this goes right back to that golden rule we talked about. Step 1, no exceptions, is to convert 120 degrees into radians. We do that by multiplying by pi over 180. Which simplifies down to 2 pi over 3. Now we can use our formula. We plug in 8 for the radius and our new angle, 2 pi over 3. So 8 squared is 64, half of that is 32. And 32 times 2 pi over 3 gives us our answer, 64 pi over 3 meters squared. For our last example, let's flip the script a bit. This time they're giving us the area, 50 square feet, and the radius, 10 feet. Our mission is to work backwards to find the angle.
So, how do we tackle this? Well, we start with a little algebra. We just need to rearrange our main formula to solve for theta. A little shuffling gives us theta equals 2 times the area divided by r squared. From here, it's easy. We just plug in the numbers. 2 times our area of 50 is 100, and our radius of 10 squared is also 100. So our angle is 100 divided by 100, which is exactly 1 radian. Knowing how to get the right answer is half the battle, but the other half is knowing all the common traps people fall into, so you can just, sidestep them completely. One of the big ones is just getting the arc length and sector area formulas mixed up. I mean, look at them side by side, they're super similar. But the key thing to lock into your brain is that sector area uses r squared. That little square should be your trigger that you're finding a two-dimensional area, not just a one-dimensional length. And here it is, the big one, the number one most common mistake I see people make. Please, 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 don't forget the 1/2. So many people just write down A equals r squared theta, and they end up with an answer that's exactly double what it should be. Just burn it into your memory. Area is 1/2 r squared theta.
It's so important.
So you've got the formula down, and you know what mistakes to watch out for. But you might be thinking, okay, why does this actually matter? Well, let's take a quick look at where sectors are hiding all around us.
I mean, come on, you see these every single day. Every single slice of a pie chart is a sector. When somebody wants to show that a category makes up, say, 25% of the total, the software behind the scenes is using the sector area formula to calculate the perfect angle so the area of that slice is exactly 1/4 of the total circle. It's literally sector area in action.
And it goes way beyond just charts. Like we talked about, those huge center pivot irrigation systems are watering crops in a giant sector shape. And engineers use this stuff all the time when they're designing things like fan blades, the teeth on gears, or even the detection range for motion sensors and radars.
And look, if you're planning on going anywhere near a STEM field, this isn't just some topic you'll learn and forget. Understanding sector area is a foundational skill. It's a stepping stone to more advanced topics in calculus, like integration, and it's a practical tool in engineering and data science. What you're learning right now is a building block for what's next. So, to wrap it all up, we've defined what a sector is, we've built the formula, and we've seen it at work. The final question I want to leave you with is this. Now that you know what to look for, where else are you going to start seeing sectors hiding out in the real world? Thanks for watching.